Exercise 8.5 sum number 8 is a 6-mark question. So as always, let's get started by finding the characteristic equation. So that is basically for the left hand side, right? So the characteristic equation, I'm going to write it as p squared minus 2p minus 3 equal to 0. So to solve this particular equation, I'm again going to use the sum and product method, where the product is going to be this into this, right? So minus 3 is my product and the sum is minus 2. So how will I get minus 3? I can write it as 3 into 1 gives me 3. But if I want to get a minus 2 while adding these two, I'm going to put it as minus 3 into 1, which when multiplied gives me minus 3 and which when added gives me minus 2. So which is good enough for me to expand this equation as p squared minus 2p is going to be written as 3p plus p minus 3 equal to 0. Again, this is an explanation only for people who do not understand sum and product method. For many of you, this might be a very trivial explanation. Okay, but anyway, I'm going to do it for the sake of the small percentage who are not yet aware of this. So this I'm going to take p common. This can be written as p minus 3, and again I'm going to take plus 1 common, so that between these two terms I'll get p minus 3. Just ensure within the brackets you always get the same number, right? So you can write this as p plus 1 into p minus 3 equal to 0. Therefore you get p is equal to minus 1 and p is equal to 3. Therefore now the CF can be written as, you have two different roots, right? So it is a e power minus x plus b e power 3x. Good, this is done. One part of it is done. Now we have to find the particular integral for sin x cos x. So that's the only difference here, right, with the previous sums. So if you see this sin x cos x, if you remember your trigonometric identities, sin x cos x can be written as sin 2x by 2, right? If you want to know why it is sin 2x by 2, yes, I can just take a small 1 minute here. You know that sin of a plus b is equal to, this again from your trigonometric identities, right? Sin a cos b plus cos a sin b, right? Now why don't you substitute, instead of a and b, I'm going to have it as x plus x, which is nothing but 2x. Therefore this becomes sin x cos x plus cos x sin x, right? So this becomes sin 2x is equal to 2 sin x cos x, right? Please don't mind my handwriting. Therefore you get sin x sin 2x by 2 is equal to sin x cos x, right? So that's exactly what we are going to substitute here. So you know that sin x cos x can be written as sin 2x by 2. So let's get started with the particular integral, right? So particular integral is going to be 1 by d squared minus 2d minus 3 into sin x cos x, right? But instead of sin x cos x, I'm going to write it as sin 2x by 2. That's right, sin 2x by 2. Okay, now I'll take the 1 by 2 common outside, and now in place of, when you have sin 2x, right, or sin any x for that matter, always remember this formula, right? When just write it here, right? So if x is equal to sine ax, as in our case here. Okay, your formula will be, your function will be of minus a squared into sine ax, right? That's the formula we are going to use. So it's going to be a function of minus a squared, always remember that. So d squared will now be equal to 1 by minus 4, right? Because it's minus a squared, and write minus 2d minus 3 as it is into sine 2x. I just brought that 1 by 2 outside. So you now have it as 1 by 2 into minus 1 by 7. Minus 1 by minus 2d. Oh, why did I put a minus sign here? It's 1 by minus 2d minus 7 into sine 2x, right? Let's take this minus sign outside, right? So it becomes minus 1 by 2 into sine 2x divided by 2d plus 7. Okay, now to further solve this equation, I am going to multiply and divide by, let me use the same color, into 2d minus 7, right? I'm going to multiply and divide by 2d minus 7. Okay, so my numerator becomes minus 1 by 2, okay, into sine 2x into 2d minus 7, and my denominator becomes, this is nothing of but the form a plus b into a minus b. You know that a plus b into a minus b is equal to a squared minus b squared. So substituting that same formula here, this becomes 4d squared minus 49. 7 squared is 49, right? So now hope you remember that wherever we have d squared, we are going to substitute it with minus a squared, right? So here a is 2. So this equation now becomes 1 by 2 into sine 2x into 2d minus 7 divided by, in place of 4 I am going to substitute minus 4, right? So 4 into minus 4 becomes minus 16 minus 49, and this can be written as, let's take the minus sign also outside. So this becomes plus 1 by 65 into 2, right? So that becomes 1 by 130 into sine 2x, right, into 2d minus 7. Okay, I am going to write this as, okay, 2d minus 7 into sine 2x. So what basically happens is that here I am going to differentiate sine 2x with respect to x, right? D is nothing but dy by dx of sine 2x. So we are basically multiplying this. So this becomes 2 into d of sine 2x is nothing but cos 2x into 2, right? And this is, the next term is just plain multiplication into sine 2x. So what do I get here? I get, so let me make some more space here. So this now becomes 1 by 130 into 4 cos 2x minus 7 sine 2x. So this is my particular integral, right? Therefore my final solution becomes y is equal to, okay, let's use a different color, y is equal to my characteristics, my CF plus PI, right? Particular integral. My CF was what? Let's go up. A e power minus x, b e power 3x, right? So it was a e power minus x plus b e power 3x, and my pi was whatever I found here, 1 by 130 into 4 cos 2x minus 7 sin 2x. So this is my final solution. So this sum doesn't probably it looks a little tough, but just remember, whenever you have a sin x cos x, you rewrite it as sin 2x by 2. That is the first step you must remember. And whenever you have something of the form sin ax, okay, in this here instead of a we having 2, but any form of sin ax, what you have to do is you have to replace d squared with minus a squared. So don't think that once you square it that minus sign becomes positive. No, it is minus into a squared, right? That is a common mistake that people will make. Okay, so that's the second step that you have to remember. So once you do that, you the next step that you have to remember is you have to cross multiply here with the inverse of this, right? If you have 2d plus 7 here, you have to multiply and divide by 2d minus 7. That's the third thing that you have to remember. And then the final thing is, once you get it of this form, remember to differentiate sin 2x here. 2d into sin 2x is nothing but 2 into differentiation of sin 2x. So that you get as 2 into cos 2x. So that's the fourth thing that you have to remember. So with these four things in mind, this is a very, very simple sum to solve. Practice 3-4 times and I'm sure you'll be able to remember it.